I actually don't know how to evaluate this definite integral using what we know in 5.3 of our textbook. We need something that comes in like 5.6 or 5.7, integration using inverse trigonometric functions. So this might be a mistake by WebAssign. I'm not sure. I guess it's something I can look into, but I can help you through this problem. What we need to do is we can first rewrite this using polynomial long division. It's often studied in pre-calculus, but basically you take the numerator and you're using long division to divide by the denominator. And usually we put the highest power first, as your goal is to find a number to multiply to x squared to make it equal x squared so that they can subtract and cancel out. So 1 times x squared makes x squared, and then carry through and multiply everything else. There's no x to the first power, so we'll carry over 0x here, then 1 times 1 makes 1. And then just like with regular long division, we subtract this by this, which makes x squared cancel out. 0x has nothing happening there, and then negative 5 subtracted by 1 makes negative 6. So that's actually the end of the long division here, because you're supposed to have only a polynomial up top, and then once you're done, there's no possibility of having like x squared, x terms with a power of x in them, so that you would multiply to make this number. This is called your remainder. You rewrite it with the remainder on top. So 1, we divide this by this, and we got 1 with a remainder of 6 over our divisor. Okay, but to see more of that topic, you'll want to look up polynomial long division. So the first one's easy. Antiderivative of 1 is x. You integrate that you evaluate that, the limits of that integral from 0 to 1, you're going to get 1 here. This one, though, requires what I was talking about over here. The substitution you can make for particular types of integrals, and again, I don't see any other way of doing this, so it's crazy that WebAssign appears to be asking this in 5.3. If you have something so that it's something that can be written as a square number plus another square number, then you can evaluate that integral using 1 over a times arctangent u over a, where u is the variable that you're integrating. So u is x in this case. So using that formula, my integral, we're starting with the antiderivative, is 1 over a. So 1 squared is still 1. So a is 1. We could write 1 over a. And then arctangent. We got a negative 6 that we have to factor out here. Forgot about that. So negative 6 is on the outside. And then it's arctangent u over a. So u, we said, is like our x variable. That's the variable we're integrating with respect to. Okay, so negative 6 is factor out. Limits of integration are 0 to 1. And still get negative 6. We want to know what arctangent 1 is, and then we're going to subtract that by what arctangent 0 is. And if you want to try to evaluate this without a calculator, we could say that arctangent of 1 should equal some number. Or you could take tangent of both sides, and you get 1 equals tangent of y. So what value, what angle would we put into a tangent function to make it equal 1? In other words, what angle would have sine over cosine equaling 1? And there's actually 2, but I think there's 2 angles that make that happen. But because you'd have a 45-degree angle, which is pi over 4, and then the other one would be, I guess I'd have to think about it, but I think the convention is to always just take the first one. So the y value we need is pi over 4, because tangent pi over 4 is 1. So there's 1 minus 6 pi over 4 minus arctangent of 0. We can do the same thing. We can rewrite that as arctangent 0 equals y, or in other words, 0 equals tangent of y. So what value for what angle would make tangent equal 0? And tangent is sine over cosine, right? Sine needs to be 0, and cosine can be anything else. That way, 0 divided by something would make 0. Sine is 0 right here at the starting point. So, in other words, arctangent of 0 should be 0. You probably get that from a calculator. Then we apply a little bit more. We get 1 minus 3 pi over 2.